Okay, let's look at the model results. And this one is only a snapshot after 100 seconds. And what's shown here is the pressure distribution, dynamic pressure. This is the Q that you have in this. Okay, but it's also just divided by constant density. Rho zero is the constant density that G. Anyway, you can convert it into a unit, which is a unit of, right? Okay, so what can you see here is you can see zones which have a positive value, the red zones, and you can see the zones which have a negative value. That's one thing. So you can identify zones where you have an elevated sea level and some where you have a depressed sea level. Okay? And you can see it's alternating. So this is a wave. Another feature that you can see, this is pressure here, that the horizontal pressure gradients become smaller. Bottom, very, very small difference. These waves actually disappear at depth. This is exactly what we wanted, short surface gravity. So now to create a little simulation is you can look at simulations of these type of patterns moving across the model domain. And it's I'll just say it again, this is a vertical slice of the ocean, of the fluid. In order to now make it a little bit, maybe a little bit more convincing of how the simulation was like, what you can do is you can convert this pressure field into equivalent sea level elevation. You can, instead of showing the results in colors, you can actually work out the vertical displacements of surfaces. Okay, so this is the pressure field expressed by equivalent sea level elevation. And here you see, look from the side and you can see the shape of the surface, and you can see how deep this signal penetrates. And only shown are here the upper 40 meters of the water color. Only the upper 40 meters because there's not much happening. Okay, and I show you the simulation here on the next slide. Hooray, let's get it going, start it. Here you can see short surface gravity. This is how the model takes shape of. And that's after the trouble of working with the SOR iteration, all that stuff. You actually get pretty cool results of short surface gravity. And I highlight again, you can use the same model by just changing the period of the waves. This is your wave paddle. We also get the other waves, which are the long surface gravity. That's pretty cool. But how can you verify whether the model is doing a good job? You can compare the vertical structure of pressure anomalies with the analytical. And this is just done here on the right-hand side, and I showed you that equation before. This is the theoretical maximum, is the red curve starting from the surface, going down to the bottom. And shown here is the dynamic pressure divided by the constant density, gravity. And these blue lines are the model. Indeed, you can, when the wave pressure disappears, it goes to 0 or so, but you can see that it captures the maximum that from the theory. And that makes you convinced that your model is. Hooray! So this is the first bit. So now you have actually the frame of this model, the frame of that model, and you can build in now other effects. Okay? So you can add other force. This is what I'm going to do. We add, for example, density stress. Let's have a look at that.